Okay, so last round of solving inequalities, and I think the only thing that could make these any harder is if when we solve for the x-intercepts, we don't have a nice factorization to do. So what do? We turn to completing the square or the quadratic formula. So that's what I'm going to do in these ones to just to make things harder. But the game plan's still the same. Also, what's challenging about letter A, unlike everything else that we've seen, we're not set equal to 0. So that's easy enough. We'll just add 11 to both sides, right? And this inequality becomes x squared plus 7x plus 11 is less than 0. At this stage, since the leading coefficient is 1, I know that we have a parabola that is opening downwards, right? So that's all I can, or excuse me, opening upwards. Okay, as far as x-intercepts are concerned, I'm going to set this equal to 0. And as promised, right, there's really not a nice factorization for this at all. So we basically turn to completing the square or the formula. And I'm not going to complete the square on this because that's a 7, and dividing 7 by 2 is 7 halves, and we're going to introduce fractions. So we might as well, to find the x-intercepts, use our quadratic formula. So I'm going to plug things in. So we're taking negative b plus or minus b squared minus a 4 times an a times a c, all of this divided by 2 times a. So now we simplify this. We got a negative 7 plus or minus the square root of 49 minus 44 all over 2. And this gives us negative 7 plus or minus the square root of 5 over 2. So they're not complex, right? So they are real. They're not nice, right? They're those irrational zeros that we talked about, I think, in 11.3. So we basically have negative 7, take away the square root of negative 5 over 2 comma 0 as an x-intercept, or negative 7 plus the square root of 5 over 2 over 0. And the square root of 5 is roughly about 2.1. So this is going to be, right, so if I started to graph this, I'm basically going to be over on the negative side. So negative 7 and then a little bit more, right? So 1, 2, 3, 4, 5, 6, 7, going about 2.1-ish, right? Right there's roughly that x-intercept. Again, this is about 2.1-ish. Take that away from 7, so we're talking a little bit under, right around, what would that be? Negative 7, that's about negative 5 divided by 2, so about negative 2.5. So we have another one right there. I have a parabola that's opening up, right? We know that from our earlier discussion. So here is a quick sketch of what this parabola looks like. All right, so again, same game plan. What was a little tougher was finding the x-intercepts. They're irrational numbers, but they're still x-intercepts. So we want to know when we're below the x-axis, so that happens down here. So we're basically in between those two zeros. We don't want to be equal to, so basically it's that region between them. So my solution would be negative 7 minus the square root of 5 comma 2, negative 7 plus the square root of 5 over 2, and then open, right? This is an interval, right? So starting at that 0 to that 0 and everybody in between is what that is basically telling us, all right? So let me go ahead, since that was a little tough and there was a lot of things to go, that took me a little over 4 minutes. So I'm going to break away and do the next one in a video coming soon. Talk to you guys later. Okay, so the last example for this particular one, again, here is our function. Only thing I can tell right away is that a is equal to 3. So I know I have, again, a parabola that's opening upwards. Next order of business is to find the x-intercepts. So I'll set this equal to 0. And then my ACers are going to shine here. 3 times 4 is 12. Two numbers that multiply up to 12 but add up to negative 6. It ain't going to happen. All right. So again, factoring's not on the table here. So we either complete the square right? Or we use the quadratic formula. Again, with that being a 3 and that being a 4, we're going to induce fractions. So I think the best way to go about this is to use our quadratic formula. So negative b plus or minus, I'm going to take b and square it, minus a 4 times an a times a c, and this is all divided by 2 times a. So cleaning this up, we have x equals 6 plus or minus square root of, negative 6 squared is 36. 4 times 3 is 12, right? Times another 4 is 48, and then over 6. So cleaning that up further, we get 6 plus or minus, I think that's going to be negative 12 all over 6. So negative 12 is 4 times 3. We're looking at 2i square roots of 3. So here's what this means. We have 6 plus or minus 2i square root of 3 over 6. These are not real, right? So this means that there are no x-intercepts. We're not going to see them on our graph. So the fact that there's no x-intercepts and the fact that I know I have a parabola opening up, again, if we really wanted some more detail, I'd find the vertex. But all I do know is that somewhere I have a parabola that is basically entirely above the x-axis, all right? And so that's what we're after here, right? We want y to be greater than or equal to 0, so we want to know when we're above the x-axis. And that basically is for all values of x. For all values of x, the graph, right, is above the x-axis. So in this case, everybody's a solution. And so I would say that the solution is from negative infinity to infinity, all right? And that is the end of that story. All right, so let me go ahead and sign off there. That wraps up chapter 11, and I will see you guys in chapter 12, where we'll talk about some exponents, and we are slowly but surely winding things down. Talk to you guys later.